Hi, my name is Gamu, and today I would like to chair an open discussion on how we can use R alongside MQL5 for algorithmic trading. My aim for this discussion is to show that it's not hard to get up and running. With a few good packages and the right framework in mind, we can get a lot done, with not that much code, right? Yeah. So let's look at how this is possible. So the first thing that you need to get started, of course, is R. You can't join the party if you're not using R. So you go ahead and download R if you don't have it already installed. I've included a link in the article. From there, we're going to be using RStudio for this setup. We're not going to be writing our commands in the R terminal directly. We're going to use RStudio as our IDE. So again, the link is in the article if you need it. And once you've got that done, we now open the R terminal to inspect the version of R that you're running. And as you can see, I'm running version 4.3.2 on my system, but I'm going to assume that maybe you're not running 4.3.2. Maybe you already have R installed and you have an earlier version. You need to upgrade to 4.3.2 or iHoles for this tutorial, because some of the packages that we're going to be relying on do not extend support to earlier versions of R. So it's going to break if you try using older versions of R. Therefore, if you don't know how to upgrade your system, that's what we're going to look at now. So assuming that you followed the first step and you downloaded version 4.3.2 of R, because in the first step, the link that I gave you always points to the most recent stable version of R that is available. So if you downloaded that and you have that on your drive, then you can open RStudio and come to Tools, Global Options. As you can see, my R version is already 4.3.2. Assuming yours is not, you click Change, and by default it's going to be on use your machine's default 64-bit version or 32-bit version, right? Depending on your architecture. And then you click choose a specific version of R. And as you can see, I have two versions on mine, right? This one, I was using this and then I tried using it, but some packages kept breaking. So I had to upgrade to 4.3.2. And you do that, you click OK, and you need to reopen RStudio for this to take effect, blah, blah, blah. Okay, we accept that. We close RStudio, we save, and we go back. Alright, okay, so good. We've installed RStudio. We're using the same version of RStudio. We're both using the IDE. Let's keep moving. So from there, you need to install certain dependencies. So the first dependency that we need is called DevTools, because DevTools allows us to install packages for R that are hosted on GitHub by other developers. DevTools relies on string I. So string I is a nested dependency. That's why it's first. So first we install string I so that we can then install DevTools. And then XTS allows us to handle time series objects in R. It's optimized for that. QuantMod allows us to calculate technical indicator values, among other things, and like plotting and all that good stuff. TTR as well. Oh, in fact, QuantMod actually uses TTR in the back, like for certain things. So we're gonna install it separately as well. And then Reticulate. Reticulate is probably the most important package here, because Reticulate allows us to interface with Python in R. So yeah, we can call Python commands, install Python libraries like NumPy, Pandas, sklearn, all that good stuff right here in R, right? Yeah. And then once all that is done, we then use DevTools to install MT5R, which is the package written for R, allowing us to communicate with the MT5 terminal. We're gonna analyze how it's doing that in more detail later on. But from there, we then import reticulate, right? And we create a virtual environment. Now, I'm not going to install the packages because I already have them installed. I am going to load reticulate. I've already created this virtual environment, so I'll just repeat that step again. In creating a virtual environment, I absolutely recommend it, right? And I hope you know why virtual environments are important, but in case you don't, you think it's a necessary step, it's necessary because some packages may depend on the same dependencies, but different versions of the same dependency. So let's say, for example, like pandas, right? You have two packages and they both rely on pandas, but then one needs pandas version X and the other needs pandas version Y. If you install them both, right, the last one that you install is going to overwrite and install that version of pandas that it needs. So that's going to break things again. And yeah, so in order to avoid those complications, just use a virtual environment and then install MT5 in the virtual environment that we just built, right? Okay. As you can see, on my system is saying requirements already satisfied because I already had it. Then we import MT5, right? There we go. And then now here, as you can see, MetaTrader 5 is not running on the machine. So we're going to initialize the terminal from R, and here we go. Oh shit, the microphone captured that. Yeah, so MT5 is now running, right? And you see this expert advisor that I've got here in the top right corner, MT5R. Yeah, that's one way that we're communicating with the MT5 terminal. But we didn't use this expert advisor to launch it. We called it from the MT5 Python library using reticulate. So from there now we can get all the usual variables that you're used to, like account information, right? So this is my demo account, right? So deriv, right? My balance, my name, the terminal information, the build, the company, the name, right? Symbol information, all that. The problem is that you can't, from my experience, I don't know, maybe I was doing something wrong, but from my experience, you can't request historical price information. I don't know what happens. It falls apart. It genuinely falls apart when I try doing that. So that pushed me to use MT5R in order to request historical price information, because reticulate in the background is trying to convert objects, R objects into Python objects and Python objects into R objects, so that it's interoperable. But then I think somehow it's having difficulty converting the prices. I don't know why, but it crashes. Like you can try it by yourself. And that's not all though. That's not all. I also couldn't log into a different account, right? Like that's just my experience with it. But anyway, so that does mean that like a limitation of this framework is that you're going to be, unless you manually log into another account, you're going to be limited to using one account if you use this framework. But like a solution could be simple. You could write a Python script that logs into another account and then just call that Python script from R. But then again, you know what I'm saying. Anyway, back to what we're doing here. So from there, we're gonna load the MT5R library. It helps us mitigate some of these issues. We're gonna load XTS and QuantMod. So from there, in order to the MT5R library uses a WebSocket connection. So it creates a WebSocket server on the expert advisor, right? This expert advisor right here is a WebSocket server, and then our R script is the client. So we send a request to the server and we get a response. So this ping test is how you check if at all the server is listening for you. From there, if you get true, then you're ready to keep moving. So we can now request historical price data, right, from the terminal using the MT5 function, mt5.getSymbol. It takes a minute. Like, okay, I'm requesting 7,000 rows of 1 minute data, right? You specify the time frame with an argument called ITF. It's a relative unit. It's relative to 1 minute. So if you specify ITF of 5, then you're asking for 5 minutes data. If you specify ITF 1440, then you're asking for daily data, right? And so on and so forth. XTS I rows is self-explanatory, the number of rows, right? XTS equals true. This is necessary for plotting. It makes plotting a lot easier because it's going to handle the dates for us, right? And you'll see what I mean right now because we're about to plot the data that we just requested. There it is. Right, there's the data that we just requested, and if you look at the bottom, you see it says January 10, 12, 13, 14. Yes. It did that automatically. So from there we can add technical indicators to this plot. That's not all we can do, right? We can obviously add technical indicators. However, note that these indicators are being added to the plot and not to the matrix, right? Not to the data frame that we have. We're only adding these indicators to the plot. To add them to the data itself, right, to our data frame, here's how we do it. Very simple. Very simple. So I'm gonna add a couple, like the moving average, the RSI, the ATR, right? From there, in order for our targets, right, we're going to approach this as a classification task, not as a regression task. So if tomorrow's close price is greater than today, or if the next candle's close price is greater than the current candle's close price, our target is 1, otherwise 0. I hope we're all on the same page there. So that's what I'm doing. I'm setting up a column to contain the next close price, and then I'm dropping any null values, NAs, right? And then I'm setting the target using this if else statement, right? So if the next close is greater than the current close, then 1 should be the value of the target, otherwise 0 should be the value of the target, right? I mean, it couldn't be simpler. So from there we set up our train test split, right? Our training set is going to be the first 4,000 values, right? And by not specifying any columns, we take all the columns, right? And then train Y is going to be the target. The train set is going to be from 4002 all the way to 4980. Notice that I left a gap in between the end of the train and the beginning of the test. You should do that too, so we don't fool ourselves. From there, we can now move on to fitting the model. Well, I'm going to use quadratic discriminant analysis, right, in order to classify these moves in the market. So to get this model, we're going to fetch it from the mass library, and then I'm going to fit the model, and we're going to take a look at the prior weights, right? So as we can see, the data is split about 50-50, dead in the middle, right? Half of the moves, half of the candles fell and half of the candles were rising. And the mean within the group, as you can see, we're not getting much separation within these groups, just using the open, high, low, and close. That's not all we could do. We could also plot. My God. Let's evaluate the model's performance. So we get the model to predict, and then from those predictions, we're going to take the class of the predictions, and we're going to look at a confusion matrix to see how well it's performing. And as we can see, our model is not performing too good. Along the diagonal axis, right, 66, this is the true number of down moves that it called, right? And this are the false down moves. So the model thought, so there were 44 instances where the model thought that price was going to fall, but it actually rose. And there were 448 instances where the model thought price was going to rise, but it fell. So it's about right in the middle. It's as good as a coin toss, really. But once we've got that set up, we really have most of what we need. We need a variable to keep track of the last trade that we opened. And once we have that set up now, we really get into the heart of the algorithm. So the first step is to fetch current market data, right, from the terminal. So again, we're going to store that in data, right? MT5 get symbol, the market symbol, the time frame, and the number of rows. And then from there, we select the very first row, because the data is arranged from the most recent at the beginning to the oldest data at the back, right? So we fetch the most recent one. That's why we're selecting 1, not 100. From there, we're going to use that in order to get a forecast from our model, right? So we pass the data on into the predict function for our QDA, right? Our quadratic discriminant analysis model. We get a forecast, and then if we have no open positions, we follow the model's forecast. So if current positions equals 0, right, we have no open positions. If the model forecasted 1, that means buy. So we buy at the minimum volume, right? And we get that from the MT5 package. And if the model forecasts 0, that means sell. We sell again at the minimum volume, and then we set the last trade to either 1 or 0 depending on what we did. That way, in future, when current positions is not equal to 0, right? When current positions is 1 or greater than 0, then we now check if the model forecasts something that goes against our last trade, then we close the trade. And reading this now, I'm realizing that I can optimize this code. But anyway, it's not necessary. If the market moves against our last trade, then we close the trade. Otherwise, if everything is fine, then we just leave it and let it be. From there, we wait 60 seconds for a new candle to form. And let's see if this works, right? So there we go, right? Fetching market information, model forecast 1. We have no open positions, opening a buy. And we come here and it bought, right? There we go. Notice also that there are stop losses and take profits that have been set by the expert advisor. I customized it, right? I customized the expert advisor to add this functionality, and I've included this customized version of the EA along with the code so that you can use it as well. And with that said, I wish you peace, love, and profitable trades, right? catch you on the next one. Let me know, what are your thoughts? How do you think we can improve this, and how could we make this more robust? I'd love to hear from you.